Alright, so now I'm going to show you some pretty neat functions. They're not really that useful for turning this thing into a pump because it's not really designed to be a pump. What this gray area is or gray volume is supposed to show is the fluid path. And what we'd like to do is now 3D print this. And in order to do that, we would actually have to have the walls in here and then hollow out the gray area. There's no easy way to do that because of the outlet here, and you would end up with conflicts here, but there is a way to easily use this gray as an outer surface and then hollow it out so that it can be printed. Not useful for making a pump. For making a pump, you'd have to do a lot more planning, but in practice, this is not a realistic model of a pump anyway, because we'd have to make it in two parts, a top half and a bottom half, so that we could take it apart and put an impeller in it. Okay, but the point here is we're going to look at some neat and useful functions. First is called a thin, and you can thin surfaces or faces, or you can thin whole bodies. And we're just going to do a whole body here. And it has to go inward, and it's going to be 1 millimeter thick. We click Generate. It doesn't look like anything's happened. In order to see what's happening inside, we can use this other function called Slice. And it's going to slice by plane. Clearly, there are other options here, but we're going to slice by plane. And we're going to slice in the YZ plane. Okay. Previously, we had one body. We now have two bodies. That's not very useful for modeling or 3D printing, but it's really good for seeing what's inside of the pump or our object and seeing that it's hollow. If you want to get an even better view, you can hide one of these bodies, and now you can really see that in fact this thing has been hollowed out. You can show that one and hide the other one, and we can see what the outlet looks like. Okay, the outlet is also hollowed out. So that's great. We know that the function worked. So what we're going to do is we're going to actually delete that slice, and we go back to having one solid. It's hollow, but we can't see it. What we're going to want to do now is we're going to want to carve out the inlet and the outlet so that we can, actually have a fluid path through this thing. In order to do that, we are going to create a new plane. It's going to be in the XZ plane or ZX plane. Create a plane, and then we need to move it in the Z direction. And I already know that the pump is 45 millimeters tall. And so, in fact, it's in exactly the right location. So we generate, and can rotate around and still see that, yes, that is in the right spot. So we want to look at this plane again, and we want to now do some sketching. We simply want to take a circle, and we need to highlight that plane, the new plane. And we didn't want that. This is the one we want. Okay. A circle. Make sure that you're at 0, 0. And in fact, if you look, it's actually really hard to get to 0, 0 because of the resolution of the grid. And so if you make sure that the snap grid is back on, go back to draw, circle, and now it should snap to 0, 0. And it does. The actual diameter, of course, doesn't matter because we're going to put in a dimension anyway. There's the dimension, and it says that it is 10 millimeters. We know that the wall itself is 1 millimeter, and what would be helpful to do would be to actually find in sketch 8 um, how big that is, or how wide that is, and that's 7 millimeters in radius, 14 millimeters in diameter, and so that means we want our circle to be 12 millimeters so that there's a millimeter left on either side. Okay, generate that, and then the next thing we want to do is extrude. And the geometry is going to be sketch 13. Sketch 13, and we are going to extrude downward. So the direction vector is going to be normal to plane 12 that we just created. And I can tell already by looking at that that the arrow is pointing in the wrong direction. It's going to extrude outward, and in fact we want to extrude downward. Alright, having a hard time getting a cursor. There we go. Okay, so now it's going to extrude downward, and it's going to go 10 millimeters. It could be much thinner than that because it's only a millimeter thick, but it actually doesn't matter because it's not going to interfere with any of the other geometries. So 2 millimeters should be sufficient, and unfortunately it's an add material and we want to cut material. There we go. So now we've cut material, and it should actually be a true inlet now. All right, now we need to get to this circular face there, and we should already have a plane. It's just a question of finding it. Okay, and there it is. Let's see, so that's plane 5. And one thing that we have to be careful about is if we start drawing immediately, it's going to put that new drawing into sketch 5, and that's actually going to mess things up pretty badly. So we just need to put a new sketch into plane 5, and then that sketch here, circle, need to be at 0, 0. Draw outward, put a dimension in. Okay, let's see. We want to get rid of one of those dimensions. It's selected. Oops, okay. Undo that. What we really need to do is select a dimension and delete it. Okay, so we still have this dimension here, which is a diameter, and we want this to be 8 millimeters because we know that this is 10 millimeters across, so we want to leave 1 millimeter on each side. Okay, generate that, it's sketch 14. We're going to do another extrude. The geometry is going to be sketch 14. The operation needs to be a cut material. The direction vector is going to be within this plane 5. We just need to flip that around. And if you do this, you can see that in fact it is going to extrude in the right direction. 2 millimeters. Generate, and there we go. Okay, so now we have something that is hollowed out and is 3D printable. Okay, it's not a realistic pump because we, generated it inward from what we said was our flow volume. But nonetheless, we can print this out and see something. Just see if the 3D printing works for us. Now to 3D print, we're just going to save the project again. And what we need to do is export. And unfortunately, you can't export in the correct format that's needed for 3D printing. But this IGES format here is actually a pretty good general format for transferring between programs. So we're going to save that. To go from the IGES to the correct format, we actually are going to need a program called Autodesk Inventor. And I'll show you that in the next video.